just in case maybe I'll need to share this to others. So alright, so let me comment this line out. So basically this is, like I said, this class is like a kind of guide on how to start or begin this project. So I didn't really have time like to form a kind of, will I say, note or something before the class, because I was still busy trying to do some work on the task. So I'll just try to start from the beginning and just try to say it as it's coming to my head. So if at any point you have any question, or because there will be plenty questions, I know. So if at any point maybe there's something I say, or there's maybe something you see in my code and you're like, why did this happen, or why did you say this, or why is it like this, just feel free to ask. So basically, first of all, what is the problem statement? For every problem you want to solve, the first thing, the most important thing is to know what are you trying to solve. And this is the biggest challenge people have. Like, they say create a shell. Like, what exactly are we, like, create a shell. Don't we already have shell? We have a shell. You can type something here and it works. So what are you exactly, what are we trying to do, right? So basically, we are trying to create our own shell program that will be a binary executable. So you know how when you create your file when you write your C code, then you do GCC and give it a name, and GCC maybe alx.c something like that -o something, or you copy that long command they used to give on the sandbox. So, and when you compile it, it creates a file, so all these green file now are executables. So we are to create our own executable where if you run it, it behaves like a prompt, like a shell program. Now there is already a basic shell program in every Linux system, right? That is what we are trying to replicate, and that shell program is sh. If I type sh here now, this sh, you can type it in your own system as long as you are using Linux or the sandbox. If you type sh, it opens something here. You can see what it's opening. It shows me a prompt with $sign in front, telling me that this is a prompt. Now this prompt does almost everything that your normal shell does. It does almost everything. If I type ls, it gives me the environment. I can type ls-la, it gives me something. I can do cd dot. I can do if I type cd dot and do ls, I've gone back. I can do cd, select a folder I want to enter into. So it is the same shell program, it does everything. And this sh I run, let me close, okay. This sh I run, this is just sh, right? It is a executable, it's a file. So basically we are meant to do our own version of this file. That's just it. That's made what this project is. We are meant to create our own binary executable where if you run it, it gives you a prompt. That's what we are meant to do. So now my own is still a work in progress. There are many things, but I'll just show you so far what I've done. If I do /simple shell, so this is my own file, I'm still working on it. If I run it now, it opens it up almost the same way, right? It opens it up. I can type. So right now, let's go to the task. Let's this is the project. What are we told to do? So let me zoom this a little bit so that you can see better. So this task 0, even me say I'm not too sure what this is, but I don't think this is an issue. Like this, they're just saying write a code that passes Betty check. So I guess they're just saying just write your code and make sure that Betty is okay with it. So I don't think this is an issue. Like, as long as your code is okay with Betty. So the main thing is from number 1. So the number 1 say write a Unix command line interpreter, usage simple shell. So this should be the name of our file. So the name of my file, if I close this, good day everyone, welcome. So it's not been long that I started. Let me just quickly run through again and just explain what's happening here. Something is happening to my computer. Okay, so welcome everyone. It's not been long we started. I'm just trying to give a kind of breakdown of what we are trying to solve. So maybe for the sake of those that just, okay, good afternoon, for the sake of those that just joined again, let me, what I was just saying is that we are trying to solve a problem, right? Before you solve a problem, you must understand the problem statement. What are you trying to do? What exactly are you trying to achieve? Now, there's a program called SH in your computer, in your Linux system. If you type SH like this, see, I type SH and I press enter, it gives me a prompt. This is shell. This is like this is called Thompson Shell. If you look at the top of this project, they told us to read on Thompson Shell. So if you check this is a Wikipedia page. This Thompson Shell is what we are. This is like the oldest version of shell. It's a very basic version of shell, and it almost every Linux system has it. So this is the Thompson Shell, and when you run the Thompson Shell, it still opens a prompt for you. Let me remove. It still opens a prompt for you. You can do the same thing you can do with your normal shell. If you want to, if you type ls, it gives you what is here. If you type cd ... it takes you back. If I type ls here, if I type ls-la, all the things you know, usually most of the commands you know, they still work. But this shell I created, this is the Thompson Shell. This is like the old shell. So there are some modern commands that bash, that normal shell has, that this old shell doesn't have. So we have many custom versions of shell. This is SH, right? This is normal shell, but we have custom versions of shell. So we have bash, BASH, which is born again shell. It is an upgraded version of shell. We have and that bash is the default one in most systems, like Ubuntu. Most of us, if you're using Linux, you're using Ubuntu. So bash is the default shell in most Linux system, and the bash means born again shell. We have other shells like ZSH. You may have heard of it if you check it online. ZSH. There are others. The two main ones I know is born again shell and ZSH, but there are others also. So this is the basic Thompson Shell, like I said, and this is what we are trying to do. We are trying to create an executable. So we are meant to write some piece of code, then compile it. Let me exit this. Compile our code using GCC, or they gave us exactly what we used to compile here actually. We say run sh. They gave us exactly what we used to compile our code, which is where's this again? Okay, this is it. This is what we used to compile our code. So here they use HSH, but here they now say it should be simple shell. So me, I'm using simple shell instead of SH. So maybe later I'll change it if I see that Betty check, but this is just the name of the file. But this is what we are going to be using to compile our code. So basically what this command is doing is, this is the GCC command to compile. These are the flags. Everything from here to this place is the flags. They are just extra flag. You can omit all this and your code will still compile. But the essence of this is to check your code for some things like variables you did not use, or functions you did not call, or maybe the way you did some comment and some kind of stuff. So these are called flags. Then this star.c, right? This star.c, this is what is responsible for, this is the thing that makes your code to compile even when you did not specify the file. So some people, if you remember when you were doing printf project, you notice that they didn't tell us what to name our file. You notice that all other projects we have been doing in ALX, they will tell us the exact name that we should give our file. Like your name should be ATOI underscore, maybe 100 hyphen ATOI, something like that. But all these projects, they didn't tell us anything to name our file. So how does the compilation work? It works because of this thing here. This is a wildcard. What this thing is doing is star.c means every file that ends with C. That's what this means. Just, it doesn't matter the name of the file. If you look at here, it doesn't matter the name, as long as the file ends with C, join it in the compilation. So because of this, it doesn't matter what you name your file, as long as it is a C file, it will join in the compilation. Then this one is just to give it a special name that you want to compile it with. So I'm just trying to give a kind of introduction for anyone that doesn't understand. So again, like I said, this tag 0 is just like, I guess it's just a basic thing. I don't really understand this, but they say write a beautiful code that passes Betty check. So I guess if you just write your code and you make sure that everything Betty is okay with it, then I don't think this is an issue. So let's start from here. Here they say write a Unix command line interpreter. This should be the file. So this is what I use as my file name, simple shell. Your shell should display a prompt and wait for the user to type a command. A command line always ends with a new line. So if you look at the one I showed you guys on if I type sh and I run it, this, look at how this is running. if I type a command like ls, it does something. When it does it finish, it gives me a prompt again to type another thing. So take note, this is important. I type something, it does what it needs to do, then gives me a command to type another thing. If I type something that is invalid, like something like this, it tells me this is not found. So whatever I type, if it is not valid, it gives me an error, but if it's valid, it does what it do. Either way, it gives me a prompt again to type something. That's what we are meant to do. So let me exit this. This is what the first condition is saying. The prompt is displayed again each time a command has been executed. The prompt is displayed again. The command lines are simple, no semicolons for now, no semicolons, no redirections, and this. So this is just very simple. The command lines are made of only one word, no argument is passed. If an executable cannot be found, print an error message and display prompt again. Handle errors. This. So just I'll explain, how I did, but let me just show you the one I've done so far. This is my own program, simple shell. So if I run /simple shell, I run it, you can see it's almost the same way like that shell I ran, but this is the one I created. So I can type now if you are typing an executable, right? For example, if I type ls, right, this file ls, first of all, let me explain something for those that don't understand what a shell program does. I've said it in another class, but maybe for anyone that doesn't know what a shell program does, right? What makes it, what is special about a shell program, that like what we are trying to do, is that a shell program executes other files. A shell program is a program that executes other files. So what that means is this: most of us know ls, most of us know echo, right? Most of us know cat, most of us know mkdir. All these commands that you are typing, all these things, different commands, each of them is a file. There's an executable file. So the way I have ss, simple shell, env, all these things are executable, right? ls is an executable. This file, this thing called ls, is actually an executable file. It is somewhere in your Linux system. It's actually in /bin/ls. This is where this ls is located. There's a file called ls. It is executable. And let me exit this. Sorry. Whenever you call whenever you call ls like this, right, your Linux system will go to that location where it is and run the file. So every Linux command you type actually is a file, is an executable file, and your shell program is running that file. That's what you are doing. So it's important for you to know that. So like I said, if I type cat, is it cat? I be echo /bin/ls. There's a file called ls. It is somewhere in your system and it is in this bin folder. There's a file called ls. In fact, let me say ls then /bin/. Now there's a folder called bin in every Linux system, and you can see all these green. All these greens, they represent different Linux commands that you may know. Grub, grep to search for files, tail. All those Linux commands you have, each of them is a specific file in your Linux system. And this is what we are trying to do. We are trying to create different executable files that do different things. So you create a file that does this, you create a file that does that, then you now have your main program, which we call that file depending on what the person typed on the terminal. So it's almost basically what we are trying to do. Now let me clear this. Now when I type ls, right here, now if I type ls, you know what ls does? It prints what is in my directory. Now what you need to know is ls is not in this my directory right now. This file called ls is not in my currently. Look at where I am. I am in, let me print my working directory. This is where I am in home, my username, desktop, dev ls. This is where I am. This is the folder I am in now. This is my current working directory. There is no file called ls here. If you look at it, there's nothing here called ls. If I type, there's no ls, but this ls still works. It doesn't give me error. If I write and if I call a file that doesn't exist, like ./alx, there is no file here called alx. It tells me no such file or directory. But if I do ls, it works, even though ls is not in my directory, right? How is this possible? Why does this work? It works because there is something called a path variable in every Linux system. So if I say echo $path, it prints the path. This path, what this is a series of folders in your Linux system, whereby if you type a command like ls, right, the system will go to those folders one by one and check if this ls is inside any one of those folders. So that's why you don't need to be in the folder of ls for ls to work, or mkdir, or all those other folders, because we have a path variable where if you run a command that is not in your current directory, right, the Linux system will go and search the folders that are specified in that path and see if this command you type is in any one of them. This executable file is in any one of them, and if it is in any one of them, it will run it. That's what happens. Now, let me give an example now. I have a folder here called execs. Look at my folder. There's a folder here called execs. If I type ls, you see that I have a folder here called execs. Inside here, I have some executable files here inside. Now, this folder execs, right? This folder here, execs, has, I want to run one of the files. Let me say ls execs. These are the files I have inside execs. Now, I want to run a file, one of them here. Now, I want to run this start, this program. All these programs, I created them. I want to run this start. If I do /start, it tells me file is not found. Why did it say file is not found? Because these files are inside a folder called execs. They are inside a folder here now called execs. So if I want to run this start now, what I need to do is execs I'll do execs /start, right? If I run it now, so why it's saying usage is because I have to pass an argument. So let me pass so start. If I pass it, you say file not found. So what this program does is just looks for a file. So let me run another one that doesn't need file. Let's say this alx, exec/alx. So you see that, let me clear this again. If I run alx, if I just do /alx, right, it doesn't work. Why? Because alx, first of all, is not in the current directory that I am. Like, it's not exactly in my directory here. There is no alx here. The alx file is inside a folder. So I need to give it the exact path that alx is, which is enter execs first, then run alx before it will work, right? Now, if it is possible, right, it is possible for me to add this execs folder. It is possible for me to add this folder to that environment variable path. That thing I printed before. Echo $path. It is possible for me to add execs to this list of paths. This is a list. It is separated by column. So from here to here is one path, one folder. From here to here is another one. From here to here is another one. It is separated by column. I can add this execs folder to this path at the beginning or at the end, so that if I want to run this alx now, I don't need to specify and say execs/. I can just run alx and it will search all of them, and since execs is part of the folder, it will go there and find the file, right? So this thing I explained now is one of the things that we are required to do in this project. But currently now for task 1 here, we are not required to do that for now. So basically what we are required to do is pass in the absolute path. Now, some of you should know this, but there's what we call absolute path and there's what we call relative path. So if I want to go to execs now, if I want to go to this folder called execs, I can type in the absolute path, the relative path. Relative path means from the current folder that you are in, how do I get to this other folder? So I just do cd, I can just do cd execs finish. This is the absolute, this is the current what did I say now? This is the relative path that I just called now. This path I wrote is relative to the current folder I'm in. So what I'm just saying is that, hey, execs is already inside the folder you are in, right? But there's what they call absolute path. absolute path. And absolute path means you must start from the home directory, not home, like from your root folder. Yes, from your root folder. So if I want to go to this exec through the absolute path, what I'll do is slash means go to the root directory. Then I can say user, is it user usr slash user slash is it home? Wait, let me see. No, there is no user. Okay, slash home, sorry, slash then home slash my username. So depending, this is my local system, I'm not using sandbox, so it may be different depending on where you're running. Then slash desktop slash alx, okay, slash dev, I have a folder slash alx slash simple shell slash exec. So now this is this is called an absolute path, right? This path now works from anywhere. This path works from anywhere. I can run it. You don't need to be in a specific folder for it to find this file. You don't need to be in a very specific folder. So this is an absolute path. So it doesn't matter what folder you are in your terminal. You can just run this and it will take you to this place. There's a reason I explained this. There's a reason I gave this explanation now. This, what we are to do in task 1 is, the way I type ls now, nobody is trying to join. The way I type ls now, we are to write a program where our shell program, right? If I run sh, this sh, remember I told you is the Thompson shell that is already in is the Thompson shell that is already inbuilt in your system. I can type ls, it works. But remember, ls is not in my current directory. The reason it works is because of that path variable. So since ls is not in my directory, it goes to check for that path. Now let me run my own. This is now my own /simple shell. This is my own program. If I type ls in my own program now, if I type ls, it tells me file is not found. This is the one I did now. It tells me file is not found. Why? Because in my program right now, I have not implemented path. Implementing path is task. Where is it? Implementing task is task 3. Handle the path variable. This is task 3. So I'm still working on this on my own. But right now I just did this task 1. So because I have not implemented task, if I type any executable file that we know, like if I type ls-la, it tells me not found. Why? Because there is nothing called ls in my current directory, right? So if I want to run ls in my program right now, I have to put the absolute path, because this thing I'm writing now is a relative path. What I'm saying is look for the file called ls in the current directory. It's not going to work because I have not implemented path in my program yet. So for me to run ls, I need to tell it /bin/ls. So this is the absolute path. Now if I run this, it works because I passed in the absolute path. So, and this is what we are expected to do. This thing now is what we are expected to do in task 1. If you see the example they gave, right? They call their program shell. This is /simple shell. This thing now here I highlight is the same thing as, let me close my program. It's the same thing as me doing this. But I named my own simple shell, they named their own shell. But this is the same thing. If I run it, it prints a $sign and gives me a space to type something. You see now, if they run their own and you can see their $sign there too, then they typed ls, right? You see, they typed ls and it says no file or directory. The same way in my own, if I type ls, no file or directory, this error message is just a custom message I put. And I'll show you all this in the code. I'm just trying to demonstrate how this is working first. I'll still explain the code like that I wrote so far to you, so that you just have an idea of how to implement it. So it tells me no such file or directory. If you now type /bin/ls here, like I said, /bin/ls, it now works. Why? Because this program right now only works with absolute path. If the file you are trying to run is not in the current directory, then it will tell you file is not found. You have to specify the absolute path of it. So that's what I'm saying. So far now, this is a command they wrote. Now, you know, if you type ls-l, ls is the executable you are trying to run. and dash L is the argument that it takes. It's an argument that it takes, right? Now, task 1, what this task 1 is saying is we should just create our program so that it only runs an executable. So you specify something like ls, or if I have something I've created, for example, there's a program here called fork. I want to run this program. I'll just do exec/fork, and it runs the program for me. This is the program I created. So let me clear this. It runs the program for me. If I say exec/fwe, it runs the program. All these things are programmed, they just do different things. So I specify the path. So what my program is doing now is I can pass in any executable file I want it to run, and it runs it. That's what it does. So they say your program should not take in, it doesn't need to take in argument. They say the command lines are simple, no semicolon, no pipe, no redirection. The command lines are made of only one word. You don't need to handle any argument for now. So that's what they said. So if you look at the example they gave, right? If you look at the example they gave, when they put /bin/ls here, it worked. You can see it gave them output when they put /bin/ls. But when they add /l in front, this is extra argument. When they added this in front, the program fails, right? So let me run my own now. I have something here called simple shell. Let me close this. Exec/simple shell. So if I say /bin/ls, it works. If I say /bin/ls-a, you see now it says no file. So this program, what I ran now is this one, this simple shell. This is the old version. This is the one I created when I did task 1 finish. This is what I created. So you can see it doesn't take in any argument. If you give space and pass another argument, it doesn't take in. This is basically what you are required to do in task 1. So write a program, it takes in only one argument, and it takes in the path to that variable, this thing you want to run. If you run any other thing that is not an executable file, it will tell you no file directory, no file, no file, no file, even if you run exit. So another thing about this Thompson shell, if I run sh right here, I have a shell. I can do many things here. If I want to exit this Thompson shell, if I want to go back, if I want to go to my normal shell, I cannot do Ctrl+C like you may think. Some of you that use Linux, you know that if you want to close a program, use Ctrl+C. Ctrl+C does not work for Thompson shell. If I want to exit this Thompson shell, I have to type exit for it to exit. So in the program now that they did, in this program now, exit also does not work. They ran exit and it doesn't work. So the only way they can close the program is to use Ctrl+C. Right? You can see exit. If you write exit, if I type exit in my own, it tells me no file. But if I do Ctrl+C, you see now it exits and it goes back to my normal shell. So this is basically what we are meant to do. Then one more thing is that if you guys you should know what pipe is, right? So there are two ways you can run your program. You can either run the program and type something in the terminal like we have just done. You can run your program and just be typing and it will be repeating, or you can pipe something into it. So you can pipe a command into the program. So here they use echo. They did echo :/bin/ls close colon, then pipe it into so me I want to pipe it into exec/simple shell.c. Okay, I think it's simple -shell. Pipe it into no such file or directory. Okay, that's because I have not implemented it in this program. So let me implement it in, and let me just do pipe it into ./simple shell. So okay, sorry, not .c, the executable file itself. No such file or directory, ./simple shell. So exec/simple shell. So echo /bin/ls, then pipe it into. So what folder am I in now? I am inside simple shell. So if I run this, if I pipe it into, they say no command found simple shell. Yes, I'm not doing this. I want to. Oh wait, am I running this through my program?
Your file should be execs. Is exec you have typed in ex. It's without
Execs.
s.
Okay, execs.
I don't know if
Okay,
that's
yeah,
the
yeah,
issue.
you're correct, you're correct.
Yeah.
I was making, okay. So you can see it works now. Let me clear this again. I echo bin this /bin/ls. I just piped it into my program, and if I run it, it works. This is how it is. Look at it. It's the same thing. So you can either type it through the terminal or you can pipe it. So I've explained basically what this is doing, what we are expected to do in task 1. So now, if there was more time, because me, I'm still working on it, I would have said, let me just clear everything and just try to run it. But there's a lot of things involved, and there's a lot of trial and error. Like, I had many bugs while trying to run this, and you know, there's a lot that it will not be possible to explain every single thing. But I'll just try and, as it's coming to my head, I'll just try and explain everything from the beginning and the different issues I encountered and why each function is necessary. So now, remember again, where's the... First of all, you are meant to create a program that when you run the program, so if I do /simple shell, if I run my program, it's supposed to print $, and then give me a space to type something, right? Print $, give me a space to type something. That's the first thing. Now, in my program, what I did is I created a string variable. Now, ideally, what you just do is printf. Use printf and print $, and space. But I noticed that printf is not allowed. Like, it's not in the allowed functions in this project. Printf is not among the allowed functions. So before I use printf to do this, but later I just say let me use write function. Let me do it in another. Let me not use printf. So what I just did is I have a character array. This is just a character pointer. This is a character pointer, and I store this $sign with space in front. So I store this. I just put it. This is what I stored it in a character pointer called prompt. Then now there's a function. There's a function that enables this to happen. There's a function that enables you to, that gives you space to type something on your terminal. It gives you when you run your program, it gives you a prompt to type. That function is called getline. Sorry, man, 3. That function is called getline. The getline function, basically, long story short, it is what, when you run the getline function, it gives you a prompt where you can type something. And then what the getline function does specifically is it reads what you typed in your terminal. If I type something in my terminal, right, the moment I press enter, if I press enter now, this thing I typed, whatever you type in your terminal goes to a place. There's a place in your system it goes to, and that place it goes to is called standard input, std in. Whenever you type something on your terminal, it goes to a place called std in. That's where it goes to. Now this getline function, this is the function here. I open the man page, so if you have time, check through the man page. What it does basically is it reads what you typed in your terminal, then it stores it in an address. So it reads what you typed in your terminal, stores it in an address that you have specified. So this is what I specified in my program, buff. This is a character pointer, and I set it to null. This is empty right now. I just created a character pointer and I set it to null. I pass this buff into my getline function. I pass the address of buff into my getline function. So what this getline function will do is it will read what is in what you typed in your terminal. It will save it inside this buffer that you created. This buffer is not allocated by me. I just set it to null. I didn't dynamically, I didn't do anything. I just created an empty buffer and set it to null. I passed the address of this buffer into getline. Getline will read what is in the terminal, and then it will count the length of what you type. So if I type something and what I typed is 20 characters, getline function will read this thing, count the number of characters, which in this case now is 20. Then it will go to this buffer that I gave it. So you see, I gave it two arguments. I gave it buff and I gave it buff size, and these two things I gave it are empty. Buff I set it to null, as you can see, and buff size I set it to 0. So I am passing their address. I am not passing the actual value, I'm passing their address. The reason I'm passing the address is because this get line needs somewhere that it will store the data it's going to read. So it reads what you typed in your terminal, stores it inside this buffer, this buff that you created, this character buffer. It stores it there. It also counts the length of the string that you typed. It counts the length and stores it in this buff size. So do you get the idea? It reads your string, stores it inside this buffer, then count how many characters it is and stores it inside buff size. Buff size is an integer. So if what I type is 20 characters, it will store 20 here, and it will store the string, whatever I typed, inside it. So it goes to, then you can specify the file descriptor that you want it to read from. So I told you that whatever you type in your terminal goes to standard inputs. Whatever you type in your terminal, it goes to standard. So I specify std in here to tell it, hey, I want you to read what is in standard input. I want you to read what is in standard input and then store it inside the buffer. I don't know if you get the explanation so far. Any question on this so far? Okay, so I assume that you understand this. So that's what getline does. You give it an empty buffer for it to store it. You give it an integer pointer. So this buff size is an integer, or size t. Size t is still technically an integer, though it's more like an unsigned integer. Then you specify.
Can I ask a question very briefly?
Yes, go ahead.
Alright, so the question I want to ask is that, like, so basically what you're saying, if I understand you clearly, is that like using getline, right, is going to technically give it the size, like it's going to allocate the size of characters you write to the memory.
Yes.
Right?
That is
Okay, so
yeah.
But does it free it at the end of the when you press enter?
It does not free it. Look at my program. At the end of my program, free buff. So when I finish my program, I free yourself. It. Yes, I have to free buff myself.
Okay.
Yes,
okay.
It does not free it. If you read the getline, let's go to the man page of getline again. They say here that returning the number of characters in either case on a successful call to getline and end will be updated to reflect this. Okay, look at it. They say if getline, if the line pointer, so if this buff size pointer that you pass is set to null before you call the function, getline will allocate a buffer for storing the line. So this buffer now, because I passed in a null pointer to getline in itself will use malloc and create and read what is in std and create a space for it. So it will use malloc and dynamically allocate memory on this address that I put. So they say here that this buffer should be freed by the user program even if getline failed. So you can see here they said when you call getline, don't forget to free the buffer, and that's why I freed it outside here. So this question you have is a very, very good question. At least I'm happy for you to ask this question. That means you are understanding. So you have to free it after you call getline. So you understand what getline does. It reads, you can set another, you can set std out or whatever. It reads from there, stores the string and stores the length of the string. Now getline has a potential of failing. So if you read the man page, if it fails, it returns -1 on failure. So this is just to handle error. So you see in this code there's a lot of error handling here, plenty. And the error handling, I'm using p error always. P error. You know, normally when we have error, usually depending on how you write your code, usually you use printf and print a message, and then you exit, maybe you return 1 or -1. But printf, I notice, I don't know if it's deliberate, but there's almost no printf function that is allowed here. Printf, dprintf, sprintf, nothing, almost no printf is allowed. The only thing that is related to print here is putchar. Is putchar even here? Even putchar is not even here, right? The closest thing here related to printing is write. Where is write? It's even write. Write is not even here. So basically, we are not. There are many.
Right is there. Right
here?
is the last.
Okay, okay. See right.
function.
Okay, yeah. See right. So if you see, we are very like constrained. Apart from right, there is no print, there is no put car, nothing, right? So, and this right is what I use to print my dollar sign. So at the beginning of my code here, I use right. You see right is what is right I use to print this thing to the terminal. Print the prompt sign dollar on the terminal. So it's right I used. So you understand what that getline function does. So now this getline function.
Can I ask a question, please?
Yes, go ahead.
Okay. I've been seeing this one is not with regards to the get line, but before the get line, I'm seeing in your while loop,
Yes.
you said y1, that is y true, and you
Not
also
from pipe.
stipulated why not from pipe. I
Okay.
think this from pipe is it a function you created
Yes.
to ensure that the pipe does not work.
Yes. This from pipe is a variable I set here. From pipe is a boolean variable.
Okay.
I'll explain this now. So
Oh, okay.
yeah. So now I'm explaining it in the order which I wrote the program, because many of these lines of code you are seeing, I had many problems, like plenty different problems on, like I will write the code, it will do something but it will not print exactly how I want it to print, it will be showing something else. I had many problems, and I'll be researching and I'll be seeing that okay, this problem you had is because you did not do this like this, you did not do that like this. So every single code you see here is here for a reason, and I put comment here to explain what they are for. So now, but just try to get the flow that I'm going with, right? I've explained the getline function. What this getline function enables you is it gives you an option here where you can type something and it stores it in that address. Now, since getline takes what you typed in your terminal and stores it in a buffer that you created, you can now call that buffer. You can read that buffer normally as a string. If you want to print it, I can just say printf %s buff. I can read it out normally. Or in this case now, since I want to perform some execution of program, right, I will read that buffer and then analyze it. So for example, I can just create an if statement that if this buffer is equal to ls, type this or something. So basically what this getline is doing for me is it is just taking what I type in the terminal and storing it in a normal character pointer so that I can read it and perform some operations on it. Now this getline function works only once. If you create a program and you just call getline, it will give you a prompt to type something. Once you press enter, it ends. It does not give you a prompt again. It does not continue giving you a prompt. It runs once. That is why I have all this code inside a while loop. So this while one means continue running forever. That is what it means. Just continue. One is always true. I can say while true. I can say while one. I can say anything that is not zero. I can put it here. While one means continue running forever. That's what it means. So
What,
yes.
what of the not pipe?
Yes.
Or like the not from pipe.
Yeah, I will explain this one now. But
Okay.
when I started writing the code, I didn't have this not pipe. I added
It was just one that was there. Right?
Yes, it was just one that was here. Yes.
Okay.
Yes.
That's why you're explaining it as if it's not there.
Exactly. Yes. So
Okay.
when I did it,
Thank
it was just one that is there. There was just one that was there. This was not there. So there is a problem I had that took me many hours, almost one day, before I now understood what was wrong. So I just implemented it like that, and you can do your own different way. So now this while loop.
Okay, you understand it, you're explaining your thought process on how you.
Yes, I'm explaining it. So the reason I'm explaining it like this,
Patient.
yes, the reason I'm explaining it like this is so that you can understand, because I wish that I had different version of my code. Like I want you to understand why every single line of code here is added, because if I remove this thing, the code still works somehow. If I remove this guy, the code still works, but everything here solves a problem. There's a problem I encountered that made me to add it, and I want to explain to you what that problem is. So I wish I had different version of my code where I've not added this thing. I would have done it, and probably that's what I'll do. I may just be removing each line one by one, and so that you can see the problem that came up that made me to add that. So now I told you the getline function, it reads in and stores the address, what you typed in a buffer, and this, right? Now this is error handling. So if there's any error, just now remember that getline creates a buffer for you. And another thing about as in getline calls malloc, it dynamically allocates memory for this buffer. So if the getline fails, right, you must free the buffer before you exit. So that's why I just have this. Now, another thing that getline does is, instead of you to pass in a buffer that is null, that is empty, right, instead of you to pass in a null buffer, if you pass in a null buffer, it will use malloc. It will, by itself, the getline function will allocate memory for you inside that buffer based on what it read. But you can decide, instead of passing null, you can decide to use malloc by yourself outside, create space. So you can say malloc size of car times 20 or something. You can just, if you have an idea of how much space you want to allocate, you can decide to allocate space first before you pass it into the getline. So now you are not passing a null pointer or this thing. You are passing a memory that is already allocated. Now, if you pass in a memory that is already allocated and the space of what you passed in cannot contain what is typed in the terminal, this getline function will do realloc. It will call realloc automatically. It will reallocate the space and expand it to be able to fit what is written. All this in are in the man page. The reason I'm explaining this getline for you like this, the reason I'm explaining it is because task 6, where is it here? Task 6 says we should write our own getline function. This is the first advanced task. So anybody that want to do it, they say we should create so this function, I'm using the original getline function, but later now I have to create my own function. I cannot use this. So task 6 says we should create our own. That's why I'm explaining this thing to you, so that anybody that cares to do task 6 should understand how this function is working. Because task 6 says don't use getline again, create it yourself. So you must understand. So this is a complex something. So getline takes in a buffer where it will store the string. If it is null, it will use malloc and create space based on what it read. If you allocate the space first before you pass it into buffer, it will check whether the space you gave it is enough to store what it reads from the terminal. If it is not enough, it will use realloc and reallocate the space before it stores it. So this getline does both malloc and realloc depending on the situation. So that's what it does. So after handling the error, right, now there's a problem I had when I was trying to read the getline function. So let me remove this code and see whether I can replicate this problem now. Let me remove this. So I want to compile this. So I'm going to use a shortcut. There's a shortcut I created. So I use SSW. Okay. So SSW. So this is my file. Then /simple shell. So /bin/ls. So okay. Now do you see I removed something here, and you see that I'm running my program now, and I put /bin/ls. This was working before, but it's not working now. This was working before, but it's not working now. Literally anything I type now does not work. There's nothing I will type that will work. Even if, no matter if it's valid, /bin/ls is not working. It will keep telling me no such file or directory. Why is this happening? I told you this took me many hours before I saw why this is happening. The reason that this is happening is because whenever you type something on your terminal and you press enter, that enter you pressed is going to add a new line character at the end of whatever you typed. That enter you pressed will add a new line. So this thing I type end with R, but if I press enter, it adds a new line at the end. And when this get line is called, it also reads the new line. So what getline we see here is it will see all this and it will see new line at the end. That's what getline gets. It gets the new line at the end as well. Now, the issue here is that this getline when it reads that string with the new line, right? There's a function, there's a function I call which is going to use that argument. This function is called execve. So I'll still explain it later, but basically this function reads the string that it is given. It reads the string that it is given. Now, the thing is that when this function sees a new line, right? When it sees a new line at the end, when it sees a new line, instead of it to read, so look at this string now. This string, I have something typed and then I have a new line at the end. Remember, instead of it to read from the beginning of the string up to the new line, it will start reading from after the new line to the end. That new line is like a delimiter. So instead of it to read from what I typed before the new line, its own interpretation is that since there is a new line here, right, it means that I should start reading this text after the new line, not before. That's its own interpretation. So if you have a string that ends with a new line and you are now reading from after the new line, you will see nothing. You will not see anything, and that's why I'm getting this error. Even if I type /bin/ls, I'm getting this error. Why? Because there is a new line at the end, and my function is reading from after the new line instead of reading before it. So in order to solve this problem, right, if I go back, what is free vector v20? So in order to solve this problem, right, this is what I removed. I replaced the new line character with a null terminator. So it's ChatGPT that told me this when I asked, after asking a lot of questions, because I asked ChatGPT like up to 5 times different. It was giving me different answers. So I phrased the question in a specific way. It now explained it to me. So I need to replace the new line. So if when getline reads something, right, if whatever it reads end with a new line, then replace it with a null terminator. That's what I'm doing here. Replace the new line with a null terminator. Once it is replaced, then because there is no new line again, it will read the string from the beginning instead of reading it from the new line. So now that I've added it back, remember, see, /bin/ls is not working. I'll close the program. I'll compile it again. Then I'll do /simple shell /bin/ls. It now works because of this thing. Replace the new line with a null terminator. So it's just something that is good for you to know. Again, this is a problem that you encounter if you are writing your code like this. So now that is one problem solved. Now we have, at this point here, we have a string. Remember, if you have any question, ask. So at this point now, we have a buffer that has, we have a buffer called buff. This buffer has our, what we typed on the terminal. It is currently stored in that place, right? Now we want to, this buffer right now is like this /bin/ls. ls is an executable file, and I want to run it through my program. I want to run this file. That's what this program is meant to do. You are meant to pass in an executable file into your program and it will run it. That's what you are trying to do now. Now we have done some basic checks and we have passed our program into it, and it is now stored inside here. Okay, before I continue this, let me explain this pipe thing quickly. Let me explain this thing, right? Now watch this. I'm going to remove, okay, first of all, let me close my program. Let me do that echo thing I did before. This is the echo I did before. So /echo/bin/ls . Okay, sorry, I need to do simple _shell. Okay, so now I told you there are 2 ways. You can either echo the command into it, or you can run it and then type it, right? Now look at this, watch this. Let me remove this. Remember, when I wrote my code, I didn't have this. Now I'm going to compile my code now. Let me compile it again. then run that echo. This is echo. Now you can see there's an issue here. It when I pass this thing through echo, right, it did what it's supposed to do. It did ls, it gives me, then it gives me an error. It's telling me error something something something. I don't understand what this error is, right? This program is supposed to work. Like, I just passed in a command and it did what it's supposed to do, but now it's giving me error somewhere. What's happening? Why do I have this issue?
Sorry, please.
Yes.
Sorry, please. Uche, sorry to cut you short.
Yeah.
Please. What are you using echo to do exactly again? This echo, like
Okay.
slash
This
ls.
this
Yeah,
echo, what is doing
Yes.
is it is writing this thing to standard input.
Okay.
Yes,
Okay.
it is writing this thing to standard input so that when you call this program, it already sees something in standard input. Something is already there. Because if nothing is
Okay.
there, it will
Okay.
give you an option to type. But it's already
I
seeing that something is there.
Yes.
You get an idea. So
Okay.
what?
Thank you. Thank
Yes.
you. Yeah, I get. I
So
get.
echo is writing this thing to standard input. Then it is passing it to the program. It's telling it, hey, program, oh, there is something in standard input. Do whatever you want to do with it. Now,
So
What-
that means it's saying that like you should first run simple shell.
Yes.
When you run simple shell,
Yes.
then there will be a stand like you have written something which is bin slash ls waiting for it to run
exactly.
again.
Yes.
All right. All
Yes.
right. Thank you.
So another thing you notice is that whenever we pipe something into the program, it is not meant to create, like, it's not meant to like continue displaying a prompt for me to type something. It's supposed to only run it once and end. If I run the program with /simple shell, it will give me a prompt and I can continue typing and it will keep repeating the prompt. But if I pipe it, right, it is meant to only work once and end. So that's one thing. These two things you need to understand. When you echo it through a pipe, it's meant to just read in that standard input once and end. But if I run the program normally, then it's meant to keep running the while loop. So how do I do that? How do I tell the program that, hey, if this guy came as a pipe, run only once, but don't keep running the while loop. If this guy came as through a pipe, but if the guy came from the terminal, like somebody is typing it live, then I want you to keep repeating the prompt. How do I tell it that? So these two problems I mentioned now, the issue of whether it came from pipe and this problem you are seeing here, right? Now, explaining this problem, I wish I had time, I would have explained. I use GDB. So when I run my program through, if I do GDB /simple shell, I do --tui. So some of you may know what GDB is, some of you may not know. I don't know. GDB is another story. So it's a program that you can use to debug. So it is through GDB I was able to see what is happening. So now, basically, again, this one is a class on its own. Explain GDB, though it's good if you can learn it. It's very, very good. I like 60% of my ALS project I debug through this. It makes it basically what it just enables you to do is run each line of your code one by one and see the output and see where it's not behaving as it's supposed to be. So hopefully maybe another time I will do a class for this. So what is happening again? Let me run this thing so that you see. This is the echo command. I ran it. It did what it's supposed to do, but it is doing something extra which I don't understand. Why am I getting this error? I was not having this before. So what is all this? What's happening is that when I typed something, right, when I pipe it into my program, what happens is it reads the program, it reads this /bin/ls first and executes its command that it's supposed to execute. It does what it's supposed to do. It reads this and does what it's supposed to do. But now, because we are in a while loop now, it will go and it will go again and try to read what is in standard input. So again, I piped this thing. I wrote the echo writes this to standard inputs. It calls the program. The program sees that, oh, there is already something in the standard input. I don't need to give a prompt for you to type. There's already something there. So it reads it and does what it needs to do, right? After it does what it needs to do, because we are in a while loop, it will go to the while loop, it will start again and try to read standard input again. Now, when it comes again, it doesn't give a prompt. It just tries to read standard input by itself. It just, like, you may think like a human, if you think about it like a human being, right? You may think that, okay, since you have read this now, right, the next option is for you to just give an empty prompt, let somebody try. But what is going to happen is that when it reads the standard input and does what it needs to do first, and you know, every time the program reads, it shifts the pointer to the end of what it read. So if it reads this thing, right, next time it is reading, it will not read it again, it will just read after it. But now it has already read this guy. So when it read this guy the first time, right, standard input is now empty. There is nothing inside standard input because it has read what is there. Standard input is empty. So when this while loop goes again the second time, it is seeing nothing. It is seeing that the standard input is empty. There is nothing inside. So because there is nothing inside, it gives error. This error handling I did there, it prints error. That is why you see every error I have in my program, I gave it a specific name: error getline, error fork, error wait, error file status, error execve. Every error has a name. So now the error we are getting here is error getline, which means this is the error here. So what's happening is that it reads what is in standard input, does what it needs to do. Now standard input is empty because it has read it. So when it's going back on the while loop again, it is trying to read standard input again directly. It is not giving prompt, it's just trying to read it. And it sees that, hey, there is nothing in this standard input, so it will give error. And that is why it prints this error. And then because this is an error, it now exits the program and stop. So it doesn't keep running the while loop. So long story short, we are getting this error because this thing was piped through the program. And remember, what do we want? We want this program to run only once whenever we use a pipe. But if we don't use a pipe, if we're using terminal, then we want it to keep running, right? So what did I do? Again, I got this suggestion from ChatGPT. There is a function called isAti. So man, I don't know whether it's here. Okay, it's in man 3. There's a function called isAti, and this function is among the allowed functions. This function is among the allowed functions. What does this function do? Simple. The function reads what is in the standard input or any file descriptor you give it. So you can pass in standard input, you can pass in standard output, you can pass in any file descriptor to it, right? In this case, I passed in standard input, std in file number. What it does, simple, long story short, is that it reads what is inside that, in this case now, it reads what is in the standard input, and it checks whether that thing came through the terminal or came through another way that is not the terminal. Its function tests whether FD is an open file descriptor referring to a terminal. Long story short, it reads what is in your standard. In this case, we are using standard input. It reads the standard input. It checks whether this thing that is in the standard input came from the terminal or it came from another place that is not the terminal. It returns 1 or 0. It returns 1
So
if...
what can another place be?
Sorry?
Like
Yeah.
what can another place be apart from terminal?
It may be through a write. Like another place is, for example, this pipe. This pipe
Okay.
is not from the terminal. You didn't type it.
Okay.
Yes, you didn't type it. Another place can be write. You may write something. You know how I wrote this thing to standard output? I can write to standard input. Anything that is not typed live like this as I'm typing is from another place. So if you use pipe or if you use another function, another program that writes it, is another place. So that's what this function does. Checks if what is in the standard input was piped into it or whether it is being typed from the terminal. If it is being typed from the terminal, it will return 1 to show that this thing that you read from standard input, somebody typed it live like this. But if it returns 0, it means it came from another place. For example, in our case, it came from a pipe. That's what this function does. So I run a while loop, right? I created a Boolean variable. It is set to false. So while 1 and this thing is false. So as long as this from pipe is false, right? run the while loop. Now it checks if the data is piped. So run is RT on the standard input. Go read the standard input, check whether it is equal to 0. So run is RT on this standard input. I check whether it is equal to 0. If it is equal to 0, right, which means it came from another means that is not the terminal, then set this variable that I created, set it to true. Remember, I set it to false before. Now I want you to set it to true.
So please, can I ask a question again?
Yes, go ahead. Yes.
In this your while condition, in your condition in this your while loop,
Yes.
it is while one and not false.
Yes.
Because pipe is, you set it to false initially, from pipe to false.
Yes.
So what you're saying that, like, while it is like while one and it is true.
Yes. Like how? Okay.
Right?
Yeah.
You understand what I'm saying?
Yeah. So while one and not false. Yeah, I get what you mean. So okay. I've not thought of it like that. Actually, I've not thought of it like that. Let me close this and see whether, if I remove the let me compile the program and see whether it will work. I've not thought of it like that. You have a point. Just like simple shell. My program runs. It doesn't give me prompt. I run the program. It doesn't give me any prompt. So it doesn't run the while loop at all. But if I put the exclamation mark and I compile it and I run my program, it gives me the prompt. So this question you asked is a very good question. Let me try and look at the code and understand why that. Because this guy is false. So if I say not this guy, it means true. So when I initialize this guy, this is false. So if I say,
But I'm thinking if you should check that is RT to check the return value. If this 0, I don't know if you yes, to check the return value. If maybe the 0 and -1 are interchanged, that's what I mean.
Okay, no, the main thing is that, like, why does it run the while loop? You know, this is a while. Before it even runs its RT, it must enter inside the while loop. Yeah. So I'm trying to understand why it enters the while loop like this, but it doesn't enter without it. So I set this guy to false. While 1 is true and while okay.
Yeah, I think
yes.
It's working because you are saying while true. That's all you're saying.
Yes, exactly.
The while loop only run when you say while true.
Yes. So the two of them must be true for the while
Why
loop.
True and not false. That is why true and true.
Yes, while true and true.
Yes, two of them must be true. Exactly.
Yes. So that is why. So you know, all this kind of thing can confuse someone.
Yes.
So both
so
of them.
I want to understand is why you now converted like from pipe to be equals to true.
Okay. Yes.
Inside this your is RT.
Yes. Okay. Yes. So look at it now. I set this guy to false. Then I say while 1 and while not false, which means while true. So while true and true, run this program. Then it checks its RT to see whether it came from pipe or not. Since it came from pipe, it will be set to 0. And since it is 0, it will change from pipe from false to true. Now, the essence of this is that when it is going through the while loop the second time, it will see that from pipe has changed from false to true. Therefore, this guy will now evaluate to false. Therefore, it will not run the while loop a second time. It will end. Do you get that?
Okay, so if I understand well, the very first time it will run with false.
Yes.
The second time when it comes back, it's meeting true.
Yes.
It's meeting true, and this not true.
Yes.
It becomes size false, so it doesn't run anymore.
Exactly. Remember what am I trying to solve? I'm trying to say, hey, if the data was passed in through a pipe, I want you to run only once. Print the result, do what you want to do, then end the program. Don't run again. Don't run the while loop again because it came through a pipe. So that's why I implemented.
I was thinking normally it's supposed to run from top to the bottom. I understand that. I understand how you explained it.
Yes.
But this is C now, and we know it runs from the top to the bottom.
Yes.
So how this if it evaluates this if statement?
Yes.
How then do you even pass? Okay, yeah, you're passing that echo command not from your own shell, but from the original shell. Okay,
yes,
I get.
Yes,
You're using an echo in your piping it, so
yes.
I get now.
Okay, you understand that? All right, all right. So that's cool. So this is why I did this.
I understand now.
All right. So this is why I added this. All these things I'm explaining, each one of them took me like, some took me like 12 hours, some took me like 1 day trying to solve which was the cause of this thing. Before I now saw that, oh, this is, and every time, sometimes asking ChatGPT is hard because ChatGPT will be giving you, if I show you my ChatGPT history, like it's like I've even lost. See, everything here is ALX, every single thing here. I make use of it heavily, but you can see that I still understand what I'm explaining for you. I'm not asking ChatGPT, then I'll just copy and paste something that I don't understand. I ask ChatGPT very, very specific thing. Why is this like this? Why is that like this? It will tell me, okay, this is why, this is why. So I understand exactly what I'm writing. It's not like I just told ChatGPT, give me something, and I just take it like that. So there's a way you need to know how to use it. And if you just ask ChatGPT, give me something that does this, ChatGPT will usually give you a function that is not allowed by ALX. That's one of the challenges. That's why I spend a lot of time, because it will give you a function. It will tell you use this function. Sorry? Hello?
You said if it is piped. Can you hear me?
Yes, I can hear you. Yes.
Can you hear me?
Yes, I can hear you. Yes.
Okay, actually, you said if it is piped, it is 0, right?
Yes.
Then if it is not piped, it is 1.
Yes.
Okay.
Yes.
Okay.
So again, it's ChatGPT that gave me this. After asking it many questions and trying to very, very long conversation, I have to put it in a very specific way. It now told me this function, and when I check and I saw that this function is allowed, I was happy. So that's what this does. So now we have solved this problem. This is another problem we have solved. How do you differentiate between what was piped and then what was entered through the terminal, right? Now let's go back to here. This is where we are now. We have replaced the new line character at the end with a null terminator. We have done that now. So now what's the next? Remember, what's our problem statement again? We want to run an executable file. So if I do /bin/ls, I want to, this is a executable file. I want you to run this executable file. If I do /exec/alx, sorry, no such file or directory. Where am I? Okay, sorry, not /exec. Remove the slash at the beginning. So if I do this, I want you to run, and if I give you a path to an executable file, I want you to run it. That's what we are trying to do, right? So now at this point here, we have stored this string. This thing I typed here now, for example, this string has been stored inside this buffer. It is here now. So now I want to execute it, right? Now there is a function, or in this case it is called a system call, that is responsible for executing programs. There is a function that is responsible for executing programs. So you call the function, you pass in an executable that you want it to execute, and it executes it. There's a function in C, or there's a system call that is responsible for that. And as some of you might know, it is called execve. Execve, right? Execute the program referred to by path name. It's executable, and this is the main this function is like the most important function in this whole project. If you look at the task page, the project page, you see where they say execve will be the core part of your shell project. So this is the main function. This is the function that you pass in the executable that you want to execute, and it runs it. So now there is something you need to know about. Again, if you have time, all these things, all these details I'm telling you, I got like 60% of them from this man page. That's why every time I call a function, I open man page. So there's a lot of information here, and all this information here is what will enable you to write your code and handle any edge case. So most of those edge case, when you write your code and your code is working, but you submit and you are having 1 or 2 check fail because you missed an edge case. Almost all the edge case you can think of is inside the man page. So anytime ALX tells you write a function, don't use the original function, write your own, create your own. This function, don't use it. We want you to create it by yourself. It's good for you to go to the man page and look at what the function takes. Look at the prototype. Every function has the prototype declared in the man page. Look at the prototype, look at what it returns, and look at the description of the function to see how it works. So that's why I'm always opening man page every time I call a function. Now there is one very important detail about this execve function. There is one very, very crazy important thing. I like to use analogy when I'm explaining something. This execve function is like a virus. In a way, it is like a virus. What do I mean by that? You see, this program, this shell, this simple shell program, my program that I called, like if I do /simple shell, like any executable at all, not just simple shell, any executable you run at all, when you run it, it creates what is called a process. It is a process, right? And a process is a program that has space on your memory. So imagine that you have your RAM. Your RAM is 1 gig, 2 gig, 4 gig, 16 gig. A space is allocated in what is called stack, S-T-A-C-K. There is what they call the stack memory. There is a space allocated for your program to run. Your program, all your variables, all your data for your program is stored in that stack memory. And it is for this program that you run. Now, look at this. When you run another now remember, see what we are doing though. We are calling a program and we are using the program to call another program. Do you see the irony of what we are trying to do? We have a program, in my case simple shell. I am trying to use my program to call another program that is somewhere. And how that is possible is through the function called execve. Now, that function, when you call that function and it calls a program, it runs a program, right? The program that it runs will take over the program that called it. I know the English is somehow. Let me try again. If you have any question, but let me explain it again. There is a program. I have a program called simple shell. I have a program. It may be another. This is my program. I run my program, and inside my program somewhere, I called execve, and I passed in another program that is somewhere else. It can be ls. It can be any of this. I pass it to it inside execve. The moment I call execve, right? So in this place now, I call execve, right? The moment you call it, execve does not return. Let's go to that man page again. They say, where is the return part? This ESV is good if you have time to take it. execve does not return. It will only return -1 if there's an error. But if there is no error, execve does not return. Execve is like, if you enter it, you cannot come back. There is no coming back again. It consumes you. What execve does is that it replaces the program that calls it. So in my case now, this my simple shell program. If I call ls through this execve, it will replace my simple shell program. And because it replaced my simple shell program, any line of code I add under the execve does not work again. It does not run. So if you have a series of code, let's say you have a simple program with a main function, just a simple program. You do something, you do something, you do something, you do something. Then you now call execve and pass in the executable you want to run. Then you now write some code under it. Every single code under the execve will not run again, because the moment you run execve, it will replace your whole program with the new program that you called through execve. This is a very important fact to understand. It replaces the caller, the program that called it, it replaces it, so it does not return. This English here is very important. It does not return if it is successful. Therefore, if I do not, there are some things here that I'll explain everything here, but generally what that means is, if I run this program once, if I let's say now after doing this part, this is where we stopped, where we replaced the null character. If I just call execve here, right, what will happen is it will run the ls command as I want. It will run it, just like I want. It will run it, but after it runs it, it will end. It will not give me a problem. Why? Because even though I have a while loop here, this while loop is saying, hey, run every code here, then run it again, then run it again, then run it again. But if I run execve somewhere here, it will just run it and replace this whole program. So even this while loop will not exist. Nothing, all this code here will not exist again. It will replace it with the program that I called through execve. So this while loop, even though I have a while loop, it will never run. It will never come back here. It's important to understand that. So how do we solve that problem? Whereby execve consumes the program that calls it. It does not come back again. How do we solve that problem? We solve that problem by creating what is called a child process using fork. There is a function called fork, F-O-R-K. What does this function do? This function, again, if you are hearing this for the first time, it may sound somehow, but I'll try and explain it. And again, if you have questions, ask, please. What fork does is it replicates this program. So again, let me give you an analogy. It gives birth to a child, long story short. So when you give birth to a child, in this case now, it replicates this program. So we have a space in our RAM, in our memory, that has all this code, that has this program. This program is running in a memory. Just imagine there's somewhere in your memory address where this program is running, when you are running it, right? Now when you call fork, what it will do is it will copy the whole of this program into another space in memory. It replicates it. Now we have two programs. Let me just demonstrate it very, very quickly. I've done this before. If you attend any of my previous class, again, let me just show it, because it's important for you to understand this thing I'm explaining, for you to understand all this. If not, it will be confusing. So I just create a file called touch alx.c. So I create a file. Let me run this. So inside this file, let me just hashtag include shell. So I'm just including this because all my declaration of it, so that I don't need to be doing hashtag include stdio. All those things I already done it in shell, so I'm just including these ones. So int main, let it just take void then I want to do a very, very basic thing. Printf hello world, or hello, let me just call my name, then slash new line and end, then return 0, because this is a main function, so you must return a number, return 0, right? This is extremely very basic project program. So let me compile this. gcc alx.c -o alx. So let me close this exec folder so that it will not confuse us. This is what I just compiled here. So if I run this /alx, we have hello, which is printed once. Very extremely basic program, right? Now I want to do something. I'm going to let me do something now. I'm going to say one dot. I'm going to copy this. I'm going to paste it 6 times, or let's say 5 times. I'll paste it 5 times under. Then let me increment all these numbers. So Control V, Control V, then G, Control A. Okay, so we have 1, 2, 3 up to 6. So I run this again. This is just it's just printing it 1 to 6 times here, right? Now watch what will happen after number 4. I'm going to call fork. So I'll just say fork open bracket. Literally there's a function called fork. I just called it. I didn't pass in anything. I didn't do anything. I just called it. I called it from number 1 to 4. After 1 to 4, I called the program. Then I did 5 to 6. If you don't know what this means, whatever it does, you just assume that the program will still print 1 to 5. But see what will happen. Compile the program and run it. Now I hope you can see this clearly. It prints 1 to 4. It prints number 1 once. It prints number 2 once. It prints number 3 once. It prints number 4 once. But when it comes to number 5 and 6, it prints number 5 and 6. Then it prints number 5 and 6 again. Why did this happen? It's because when I called fork, this program became 2. It became 2 places, and when it multiplied, the 2 programs are running at the same time. I just created another process, and the 2 programs are running at the same time. So if I call fork, every single code I write under this fork is going to be executed in the 2 programs at the same time. That's why you see this thing printed 2 times. So I created another process. Now there are 2 processes. After this fork, there are 2 processes running. And again, just imagine that I have this code here. Then imagine I have this code in another place, just in 2 places. Both of them are running the same line by line. They are running at the same time. There are 2 processes running exactly at the same time. This one is doing, this one is doing, this one is doing, this one is doing. They are running at the same time. It just multiplied. So Now there are two processes. The process that called the original program, this my original program that called this fork, is called the parent process. And then the child that I created, the other process that I created, is called the child process. So we have the parent process and the child process. Now there's some explanation. If you want to, I can call fork multiple times. If I call fork multiple times, each of the process, so if I do like this, right? Now when I called fork first time, before I called fork, I had only one program. So when I called fork, that one program created, it gave birth to a child, and now there are two. Now we have two programs after this first fork. If I call fork again, right, each of the two programs we give birth. We had one. I created fork, it now became two. We now have two programs running at the same time. If you call fork again, each of those two programs we give birth, so it will now become 4. If I call fork again, we have now, after the second fork, we have 4 programs. If I call fork again, each of those 4 programs we give birth to a child, and it will become 8. That may not be too, it's not really, we are not really going that far. We are not in this project. I don't think we are creating more than one fork, but it's just important for you to just understand how fork works. Again, please feel free to ask questions. Sometimes I feel as if maybe my network has disconnected and I'm just talking to nobody. So again, feel free to ask questions if you have. So this is what fork does. Now
we can hear you.
Sorry?
We can hear you.
Okay. All right. So so that's what fork does. It creates two processes. Now when you create a process, every process that is running on the system has something called process ID, PID. Every process in a system has what is called PID, process ID. So now watch this. I'm going to let me delete this fork, right? So this is my program, the way I run it. So I'm going to create a variable PID, right? Then I'll say let me just do this. At the end of the program, I'm going to say PID is equal to get PID. There's a function called get PID. So what this function does is it returns the PID, and I need to also print the PID. So let me just print it at the end. So PID is percent, I think it's percent %u, then @n at the end, then comma PID. Okay, so if I run this now, you see PID is this is the process ID of this program that I'm running. This is the process ID. Every program has it, and every time you run it, the process ID changes. Every single time you run it, 466, 509, 531, it's always giving it a new process ID every time you run it. So now if I create a fork, right, if I go to this place now, fork, I called fork, right? Remember I told you that whenever you call fork, every single code you have under we run 2 times, because now we have 2 programs that are running the same code. So because I called fork here, right, the parent process is going to do get PID, and the child process is going to also do get PID. So the parent process will print its own PID, and the child process will print its own PID, and both of them have different PIDs. That's what I want you to understand. The parent process has its own PID, and the child process has its own PID. If I run this code like this now, so if I run this code like this now, let me run this. So for anybody joining, or if you didn't start from the beginning, I'm recording this, so after the class I'll just edit and compress the video and upload it to Drive and send the link. So even if you didn't join the class at the beginning, so if I run the program like this now, ALX, right, you see there are 2 PIDs printed. There's PID is 52670 and PID is 52671. You can see that these two PIDs are different. So what happened here is that the parent printed his own PID and the child printed his own PID. Now the essence of this PID, right, is so that you can give specific instruction to each of the process. So ideally now I can now come and say, okay, you process, this particular process that has this PID, I want you to do this particular thing, whereas this other process I want you to do something. So you can have different forks. For example, remember I told you I called fork once. I have two programs. I can call fork 3 times, 4 times, 10 times, create 5 processes, create 20 processes, and each of those processes I can specify and say, okay, you, this process I want you to do this, you, this process I want you to do this. One of the easiest example I can give for fork is your browser. You see my browser has many tabs. Each of these tabs in my browser is, you can see it as a fork. Every single tab, each tab, when you create a new tab, it's like a fork. That's what you're doing. You're creating a new process. It is still your tab or your browser, but you are creating a new process. This is an analogy I usually give. So that's what is happening. So you are creating a new process every time you create a new tab. So each tab is doing a different thing. It is the same program, but each tab is running a different thing based on the URL that you typed. So that is what this fork does. So now, there is something you need to know. Whenever you call fork, let me comment this out. VGB. Let me comment this out. Then let me say PID is equal to fork. Now, whenever you call fork, whenever you call this program, right, it returns something. It returns a number. There are 3 possible numbers it can return. If there is an error with fork, if this fork has an error, it returns -1. Now it can either return -1, or it returns 0, or it returns a number that is greater than 0. If there is an error, it will return 0. Now it will return -1. Now remember that I told you this program is 2. It is running 2 times. There are 2 different programs and each of them has a PID. This fork line, this line of fork is, because I've created 2 programs, this thing is in the 2 programs. Both of these 2 programs have this. So if I print PID, if I print this PID now from the parent process, it will give me a number that is greater than 0. But if I print this PID of fork, if I print it from the child process, it will give me 0. I know this is somehow, I know what I just explained somehow. Let me remove this. Let me just I'll run it now so that you see. I put this up so that it will not print 2 times again. I want this is the only thing I want now to print. When you call fork in the parent process, it returns a number greater than 0. But in the child process, remember there are 2 programs, there are 2 processes running, and they are running this thing at the same time. In the child process, it will return 0. So if I print this thing now, watch what will happen. You see I have a number greater than 0 and I have 0. What is this indicating? This is indicating that, hey, if, again like I said, if this fork from the parent process, it will return a number that is greater than 0, but from the child process it will return 0. Why is this important? Why is this thing now important? The reason it is important now is that I don't want, after calling fork, I don't want the code under to be run by all my program. I don't want both the parent and the child to run the same process. There is no use in this case now. The reason I want to create fork, the reason I created a fork is because I want to be able to tell my child to do something specifically for me. I want to be able to say, hey, you, my child, you are the one that I just created. I want you to do this specific thing. I don't want to do it. Again, I printed PID. I want this PID to only be printed by the child. I don't want the parent to print PID. I want the parent is like the commander of the army. He creates children. The commander does not go to war. He sends his army, his soldier. If the soldier dies, he sends another soldier. I want to be able to create children and send them to do things for me. I don't want to go, I'm not going by myself. So you child, go and do this, you go and do this. How can I do that in this case? How can I set this thing to print for only the child to print? Simple. If PID is equal to 0, then do this. Finish. Now you see that here it printed 2 times, but now if I run the program again, it prints only once. Now I put a single printf statement here, but ideally I can write a large amount of code under, or I can call a function. What I just did is I have a program. Sorry, one. Sorry about that. Can you still hear me? Hello?
Yes, we can hear you.
All right.
I can.
So,
I can hear you.
So, I don't know if you understand what I just explained. I use an if statement and say, okay, hey, if you are the child process, I want you to perform this function. I want you to do all these things, right? So, what I just did now, it is only the child process that will execute the code that I did. Now, why is this important? It goes back to where we are coming from in our simple shell. Remember, I told you that the execve function consumes the program that calls it, and it does not come back. So now, if I create a fork, this is a error check. This one is just to check whether the fork fails. If I create a fork, and I'll say, hey, if this is the child process, if you are the child process, then I want you to run the command. This exe is just a constant function I created, but this function is what calls the execve, right? So what I'm just doing now is, hey, if you are the child process, right, I want you to execute this program, and I pass in all the arguments. Now, why is it important? When you execute the program, remember that the program will consume the child. The child will not exist again because I'm now running a new program. If I run ls will take over my child, and it will never come back. And when it runs ls, my child will die. The program does not come back, it ends. But now, because it is the child that ran the process, the parent still exists. Remember, there are 2 programs. The parent program still exists. So what I'm just doing there is, hey, my child, I want you to go to battle and fight this guy. If you die, fine, I'll create another child. That's what I just did here now. If this is the child process, you can execute the command. The command you execute will consume you, so you will not exist again, you will die. So when this finishes, the child will die. And because the child died, it will come back to the parent process. The parent process is still running. So because the parent process is still running, the parent will just give birth to another child. So now, there's something you need to know. When you create a fork, I explained this, that your program is running concurrently. So the parent and the child are running at the same time. The line of code are running. So if your child is running line 48, the parent will also run line 48. If the child run line 49, the parent will run line 49. So now, we need to tell the parent, whenever you run your program, right? Ideally speaking, the parent is supposed to wait for the child to do what it is doing, finish, before the parent continues. The parent is supposed to wait. You are not supposed to run at the same time. The parent is supposed to wait. So now, how can I tell the parent to wait? There's a function called wait. There's a function called wait. What that function does, long story short, is that it tells a particular process to wait until a condition is met. So there are two functions. If you check the intranet, we have there are two alert functions. We have wait and we have wait PID. In fact, we have many wait functions, but these are the two I've used so far: wait and wait PID. So the difference between wait and wait PID mainly is that wait, just tells it, hey, I want you to wait until all the other processes are run. While wait PID just tells it, hey, I want you to wait for this particular process. So imagine you have 4 children, and each of those children has their own PID. I want you to wait for this specific child that has this specific PID. You use wait PID and pass in the PID of that child. But if you want it to just wait until the children, then you just use wait. So in this case, I just use wait PID. I can still use wait. Before I use wait, but here now I'm using wait PID. Before I use wait, and it still works. You can check how this wait PID function works.
Can I ask a question?
Yes.
Okay, so like you said, each child process, right, has its own PID.
Yes.
Right.
Yes.
And but if you use fork,
yes,
what happens is that like that child PID
yes,
is set to like it returns 0. Let's
yes,
just call it that.
Yes.
Right? Not that the PID is 0, it's just returning.
It's just 0. Returning 0. Yes. So what happens is
so
that
if I'm going to use this, okay, go ahead, please go ahead.
Okay. So what that fork is doing is that it is returning a number. Now, the fork returns the PID of the child process to the parent. So when you call fork, remember we have 2 processes. We have the parent, we have the child. On the parent, the fork will return the PID of the child, the original PID of the child. But inside the child, the fork will return 0. 0 doesn't mean that the PID of the child is 0. The 0 is just indicating that this is the child. Remember when I started, I printed the PID of both of them, and they have numbers. Both of them have PID that is greater than 0. This fork is just trying to indicate what is the parent and what is not the parent. So it returns the PID of the child. So if you call fork 3 times, each of those fork will create children, and each of those children has their own PID. It will return the PID of that child.
Okay, that's 0.
Yes.
Okay.
Yeah, go ahead.
That's 0. I saw a video somewhere, and when I tried it out, from what I saw in that video, the thing is, when you call a child process, basically, it doesn't just execute, and then while it is executing at that moment,
yes,
it is no longer under the parent, because the parent has left the memory at that particular instant. So while it's executing, it's what's actually running the child at that time is the actual shell itself. Because if you check your shell, there's a command you use to check, you will see that for every shell, there's a particular program that is executing at that time, and that program's PID is 0. So that's what this child will take as its current PID, because of the original PID of the parent that is adopting it, the adopting parent, before he finishes the process.
Yeah.
That's
okay.
Why I saw.
Okay. I guess that's why I've not like researched it like that. So, but I guess that maybe that's why it returns 0. So, but basically the same thing. So the child returns 0 on the fork, but the parent.
Sorry, but the adopting parent is the init function, but its own this thing is 1, not 0.
Sorry.
It is 1, not 0. He was talking about it adopting the parent's ID.
Yes.
The parent's ID that adopted the child has the initial value of 1, not 0.
That is something greater than
1.
No.
When I say adopting parent, I don't mean the actual process. It's not the actual, not this process. When you create a program, like which I explained now,
yes,
the program will go into the memory.
Yes.
That's like your RAM. No, not this process. For every shell that you have. Yes.
For every shell that you have, the adopting parent is the init process. That's the mother process.
Yes, the init process. Yes, exactly.
The PID is 1, not 0.
That is for the parent process, right?
Is that actually 1? Okay.
It's not
exactly. Yes, that parent process.
It's not exactly 1, right?
I'm trying to correct him. He was saying it is 0. I'm saying it is not that. That's not why
I get what
you're
saying.
Okay, yeah.
That one is 1, not 0, yeah.
Okay, yeah.
Okay. But I still have a question with regards to that invert. I'm just waiting for you to finish. I have a question with regards to the execve. There's somewhere I want.
Okay, all right. So let me quickly continue. So again, you understand the analogy. So basically, what I'm doing is, I've created a child. So I'm now saying, hey, if you are the child, right, I want you to execute this command. But remember that the parent is still running at the same time. Now, while the child is executing this command, the parent will try and go to the next while loop, right? So if I did not wait, what will happen is that the child will be running and the parent will go to the next while loop. That's what is going to happen. So I need to tell the parent to wait until the child finish before it goes to the next while loop. Somebody's mic is on. So you get what's happening. That's why we have wait. So this wait PID, I pass in the PID of the child that I want to run. Then this W status is just a variable that stores information on the child. So a child can die. There are different ways a child can die. There are many ways. If I go to Mantu wait, there's what they call I don't know if it's here. Okay, look, these are different things. There are different things that can make a child. Okay, this is not it actually. There's what it calls start. Here, look at it. There's W exited, there's W stopped, W continued, W on, and there are still others that are not here. So okay, look at others. There are many of them. There are many things. So there are many things that can make a child to die. It can be that the child exited normally. It did what it's supposed to do and exited. It can be that something forced the child to stop. It can be that there's an error somewhere in the child and it ended. There are so many things, and all these things have status. All of them. They are different things. W if exited means it exited normally, terminated normally. W if signal means return true if the process was terminated by a signal. So the status, whatever this status is, right, when the child ends, is what is stored inside here. And this W status, I declared it on top. It's an integer. So I just created an integer, W status. Then what I'm saying is, hey, when you call the wait PID, I want you to store the status. So when the child dies, as you are waiting for the child, when the child ends, I want you to store the status of that child. Then this 0 is a file descriptor, something like that. So there is some kind of explanation for it, but long story short, it's just a file descriptor of where you are reading it from or to, something like that. So there's the way it is. I don't fully understand it. Now, this wait PID can also return error. Remember, we are doing a lot of error handling. So that's why I put it in an if statement. So if you are trying to wait and there's an error, then print error and exit. So that's why I just wrote the code like this. I can still do this thing outside and just say if is equal to -1. So this is error handling, all this thing. But basically, you understand what this is. So while the child is executing, wait. When the child finishes, then you can continue. Now, since this thing will now execute the command and ends and dies, then it comes back to the program, and the wait status now sees that, okay, the child has ended. Then it goes to the next while loop and does the get line again and do everything, and it comes to this place and it creates another new child because the former child has died. That's the cycle that is happening here now. So I don't know, time has gone and my storage is getting filled up, so I just want to end it now then, so that I can just compile the video and maybe try and send it. Then maybe we'll have another time. So let me answer any question now so far. I know there are still many things, but let me just try to answer any questions you have for now.
Okay. Please, I have a question, please.
Okay.
Okay. Based on the shell, I've worked on my own to the point that, let me say, you can include the full part so that it will run the command. But in the sense that, let me say, you are not supposed to put that full part now only to execute the command like ls now.
Yes.
You just need to type ls and try to implement that.
Yeah.
But I'm confused on that point. And I think there's a way I was reading that there's a way I will use the part.
Yes.
The part variable to do that.
Yes.
But can you just put me a hint on how to go about it?
Okay, so this question you asked is exactly what I'm also working on now. I even, in fact, let me even show you. Where is it? Where did I call that thing now? Okay, this is memory leak. So I am currently trying to work on that. So I understand what is needed to be done. So just like you said, there's a path variable, right? So I'll show you guys something now. I'll show you something quickly. I just want to show you conversation now that I'm having with ChatGPT.
Okay.
Yes. So you can see now I want to write a C program that takes a file path and searches for it in the current path. This is the question you just asked me now. So something like that. So it just searches for the file in the current path in a way. So long story short, you want to hello?
Yeah, I'm seeing.
Okay, so you want to do it so that you can type ls instead of putting the full path, right? So
Yes.
so me too, I have not done this one yet in my own. So what I want to do now is like the flow that I'm planning to go with now is that I will when you type a command, so I don't know how your code is structured, but in my code now, what I will do is before I create this fork, I will check if this file exists. I'll run a check. Now I have a function called check file. I created it, check file status. So this is a function I created. It uses start. There's a function called start to check if a file exists. So I will call this function before I create fork. So in the ALX tags, there's somewhere they said implement path, that number 3. They say implement path, fork must not be called if the command does not exist. So you must not create a new
fork must not be called.
Yes, it must not be called. So in other words, the way I wrote my program now, I'm creating fork. Then I'm now running this function executes. Then it is inside my function that I'm checking if the file exists. This is my function, right? So this is not, I'm not supposed to do it according to ALX now. I'm supposed to move this check outside here and put it before this fork. So I'm supposed to check if the file exists first before. If the file doesn't exist, I'll print error. If it exists, then I can now create a new child. That's what ALX is saying here. So now I will check if the file exists. So now, you know, if you type ls like this now in your program, it will tell you no file because you did not put the full path. It will tell you no file.
Yes.
So
Yes.
if I check for the file and it tells me no file found, right? If it tells me no file found, what I'll now do is I will call the environment variable. Now, first of all, there are many things involved though. There are a lot of things involved here. First of all, right, you need to know how to read the path. So I can read path. I showed you guys how to just print the path normally, right? This is the part of your system. Now we need to be able to pass this path into our exe function, right? Now exeve takes 3 arguments. Exeve, where is the function? This thing, it takes 3 arguments. The first argument is the name of the program you want to run. The second argument is an array of all the arguments that are going to be passed into your program, including the program name itself. So the first argument of argv should be the name of your program. I'm sure you understand this. So the first argument must be the name of your program, and then the subsequent argument are the parameters or the argument that you are passing into the function. Then this env here is environment variable, right? Now there are two ways you can do env. You can either create your own env. Now env is a series of key value pairs that contains the variables. So if you look at paths, let me not path now, let me print env so that I see. You see that everything here is something equal to something, something equal to something, something equal to something, something in capital letter equal to something, something in capital letter, including the path. There's somewhere you see path.
A variable and a value. Right?
Yes, a variable and a value. So now these variables, all these things here, right, I can pass it into my exeve function. I can pass it into it. Now how do I get this? There are 2 ways you can get this. You can get this by adding in your main function. You know, not most of us know argc and argv, but you may not know that you can add a third argument called give it a name, whatever. I named it env. You can give it any name. This third argument is what contains the environment variable of your system. Let me show you something. Sorry, let me show you something. Let me remove this, delete this. Int arg c comma in car star arg v star then comma car star env, right? Then I can say for let me just say int x for x equal to 0, while env x is not equal to null, then x plus plus, right? I can say print f open bracket ended this percent s new line, and this is it percent s? Sorry, I need to add a variable. So percent s, then env x. Now I didn't define env anywhere. I'm just printing. I just passed it here. I didn't define. Now I'm going to run the program. Look at this thing. This is all these things was printed by print env. All these things. Now see what will happen. I'm going to compile it. So here, like, do I still have that compile? This is it. I'm going to compile my program and run it. This ALX, this program, I'm going to run it now. /ALX. You see that it printed the exact same thing that print env does. It printed the exact thing. So whenever you add this third argument in your main function, it passes in the environment, all your environment variable into the function. It passes it in there. So that you can get all your environment variable through this. So what I did in my program is that I pass it into my main function. Then this env, I now pass it into this execute function that I created. I pass it here, and then when it goes into the execute function, it passes it into my execve function as the third argument. So I said this is the third argument of my execve. So this is the env, and I'm passing it into the execute. So what I'm planning to do, right? What I'm planning to do now is I will create a function that reads this array of strings. I'll create a function that reads this, and you can specify the variable that you want. So if I pass in path, path, right, it will go through this thing and look for the one that is path. So here now, path is somewhere here. Where's path? It will go here and bring out what is path. Right now, there is an inbuilt function that does this called getEnv. If you just put getEnv and put path inside it in quotation, it will give you the path. But I'm not sure that inbuilt function is allowed. I'm still trying to see whether it's allowed. But from what I see, it's not really allowed. We need to do it ourselves. So they so
we should create it ourselves.
Create it ourselves. So you create a function. Yeah, go ahead. Yeah.
That execute function you create,
yes.
you are running on top.
Yes.
What does it do? What does it do? Like that execute function.
Okay, that okay. It just calls my, like, you know, when you are calling the execve, there are some things you need to put in place. So instead of me to call the execve directly there, right, I just created a function where I just put something. So what my function is doing is, okay, first of all, there are some things. Okay, I've already done some extra things in my program. Like my program now, if I run it, /simple shell. If I run my program now takes in extra argument. I can do /bin/ls-la, and it works. I've done my program now to take in arguments. So I can add in extra argument in my program. I can make a file. I can say /bin/mkdir alx /bin/mkdir alx. I'm creating a folder called alx inside here. If I press enter, look at this place. Okay, cannot create file exists. Okay, there's already a file called alx. Let me do /bin/mkdir. Let me create my name, Uche, UCHE. You see, it creates a folder. I can do /bin/rmdir Uche, and it will delete the folder. So I've done my program to take in extra argument. So how did I do this? I use a function that split. So you know, when I type this thing now, like this /bin/uche I typed, it is a single string. This thing now is one string. Anything you type, whatever you type, no matter how, it is read as one long string from the beginning to the end, right? So you need a function that can split this string into separate words. You need a function that can split it. There's an inbuilt function called strtok. So strtok, there's an inbuilt function.
String talk,
Sorry?
This string talk.
Yes, string
String
talk.
talk.
Yes. So that's what it does.
Okay, yeah.
So what
I
string
think
talk?
I've implemented that.
You have used it, right?
Yes.
Okay. So what string talk does is it when you call string talk when you pass in a string and you call string talk, it gives you the words one by one. So it's almost like that variadic function where you are calling
Okay.
va args, and every time you want to get one variable, you must call va args every single time. If you have 10 variables, you must call var 10 times. So here, if you have a string that has 10 words, then you must call strtok 10 times. It will be giving you each word one by one. So that's how it works. So, but the thing now is that there is somewhere in tax 7 or tax 8 where they say we should not use strtok, even though strtok is among the allowed function. So from number 0 to number 6, you can use this strtok, the inbuilt one. But from number 7, they say we should not use it. So what I did is I created my own function. And this one took me another time. This one took me like almost more than 1 day to create it. So I created a function called split string. So what the function does basically is to, okay, no, this is not it. This is it. So I created a function that, what this function does is it takes in a string with it takes in a string, and it takes in what is called delimiters. So you know what delimiter is? Delimiter is what do you want to separate the string by. So are you is it separated by space, or is it separated by comma, or is it separated by semicolon? For example, if you look at the path variable, your path is not separated by space, it's separated by colon, right? You can see. So if I want to split this part now, I will not split it by space, I'll split it by colon. So what the function does is it takes in a string that you have, one string, and it takes in the separator, what you want to separate it by, then it creates a vector. So you know what vector is? Array of strings. So it dynamically allocates a vector and then separates each word into its own pointer. So it basically just splits a string into different words and gives you an array. That's what it does. So I created my own function. So you will see that in this simple shell.c, in this exec function, I called in split string. So basically I'm trying to split this string into different arguments. So I call in split string, I pass in this argument is the string that I typed from my terminal. That's what is here. Then I pass in the delimiter. So in this case I'm using space. That's why I just put double quote with space. I'm saying, hey, separate this word by the space, and then store, when you separate this word and space, store it inside a double array. So you know this is a double array, this is a vector, so store it inside. That's why I pass in the address. So what I'm just saying is, hey, split this string and store it here, so that instead of me to have it as one long string, I'll have it as separate words. So I need to do it like that so that I can now pass it into the execve function. So when you have split the string, right, when you have split the string into multiple words, what I'm going to now do next is again we are trying to handle the environment variable. That is, we are trying to do it so that if I type ls, it works instead of putting the full part, right? So what I'll do is I will check. Remember I told you at the beginning, I will check first if the file exists. If the file does not exist, so I have a function that checks if the file exists. If I check and the file does not exist, right, what it's going to do is I will create a function. What that function will do is this. This is the main thing. Now this, I'm telling you the way I want to go about it. It will take this path variable. Remember, I'm sure you would have before then you would have maybe created a you know how you are going to get this thing. Just find a way to get this path variable first. Find a way to get this. Then when you get this, right, use your function that you create to split string, use it and split this part. So this is one part, this is another part, this is another part. Split it by the colon, right? Split the part by the colon. So you will now have a vector whereby it has different words, and each of them is a single part. So what I'm going to do is, for each part that you separate, right, I'm going to append ls. For example, now I typed ls, right? So what I'm going to do is, after this slash bin, I'm going to put slash ls in the end. So I'm going to create a function that joins the two string. So you see there are different functions you're going to create. I'm going to create a function that will take this first part, that will take a string and join it with another string. The first string is the first part it got. Then the second string is what you entered, the executable file you entered. So I'm going to concatenate this string with that command that I typed. When you concatenate it, it will now be like this. It will be /home/this/bin/ls. When it concatenate it, I'll now run this through the file checker. Use my function to check if the file exists now. If the file doesn't exist, I'll go to the next path variable and do the same thing. Get the whole path. At the end of the path, to do add a slash, then add the command that I typed in the terminal. Add it, check if the file exists. If it doesn't exist, I will take the next one. So I don't know if you understand the flow I'm explaining now.
Yeah.
So that's what I plan to do. I know it's not going to be easy, it will take time, but that's what we have to do, because ALS has restricted us from using some variables, some functions. If not, they are easy. It's very easy to do. Just call the right function.
Okay, I don't quite understand. I don't quite understand.
Okay.
I was thinking that one is now the method you talked about. I understand it, but you create a function that will do this automatically, and it doesn't do it for only ls. It does it for other commands as well.
Yes, it does it for other commands. So it takes in. It's like
a variable.
Yes, it does it for any command. So basically, when you type a command, so if I type mkdir or whatever, right?
Yes.
If this command doesn't exist, in this case, it says no file directory, right? It means it is most likely a executable file that is not in my current directory. So I want to find the directory which this file exists in. So what I'll do is, for example, now, yeah.
Yes.
Go ahead. You wanted to ask something?
Sorry. I need to understand what two things is. One, if it already exists in the bin directory, because that's mostly the bin is already declared in the path.
Yes.
By default.
Yes.
That's the bin.
Yes.
The path by default. If it exists there.
Yes.
That means you can use execve to access it now, right?
Yes, you can use execve to access it here, but because we are using like as far as I know, you can't like just automatically tell it, like it doesn't work automatically. If I've already passed my path variable inside execve, so if it works automatic, it would have worked. I will not be getting this error. That's right, if it works. So even though execve,
this one is because they said you should handle the path.
Yes,
that's why you have to do that.
Yes, that's why I'm doing this. Yes, because they say.
Another thing as well is sometimes I also observe that if you move an executable file, let's say you created your own executable file that you're using for a particular function, let's say for git push, for instance.
Yes.
And you move that file to the bin directory.
Yes.
Automatically, that file can be accessed from anywhere.
Yes. It can be accessed from anywhere. Hello?
Yeah. So one of the things I don't add to debugging is that ls, though all those commands are located on the bin, all those are executable commands.
Yes.
So first, if you want to see that if it must add an ls, I think that part now can searches for the file ls inside of that directory.
Yes.
Without adding ls as well.
Yes.
So if you just pass the path on that env, the last command on that exv, they will pass ls. It will now look for that file inside of that environment variable rather than
Sorry, what are environment variables again?
Okay, environment variables is basic. When you do print env, let me do print env. Everything here is environment variable. All these are environment. So environment variable are basically key value pairs, right? You have something equal to something, so it's like key value pair. Something in capital letter is equal to something. So these are the inbuilt environment. These are the inbuilt environment variables in your computer. All this. So if you want to print a variable, every single way, there are many variables here. If I want to print any of the variable, one of the variables here is let me say lang. One of the variable here is called lang. Lang equal to ing. If I put print $lang, it prints eng, right? I can print any of these things here. So when you print parts, when you do something like print $part, It prints part. Why? Because there's a variable here called part. Where is it? This is a variable here called part. So all these are environment variables. Now these are the default inbuilt ones. You can create new ones. So your username is like this. My username. Username is equal to this. It has some important information about your computer, about the user, about some stuff like that. So these are the inbuilt ones. You can also create new ones and delete the ones that are available. So it is from this environment. There is one of the important ones for us is this one called part, because this is where your computer searches for those commands like ls, like mkdir. It searches for it in those parts. So that's why you don't need to type their full part, even though ls is not in my current folder, but it still works because it goes and searches for it there. So I don't know if you get.
Okay, I get that. Thank you.
All right. So
yeah, my question.
Yeah.
Actually.
Yeah. So concerning the.
Yeah, I said.
Yeah.
I said.
Yeah, go ahead.
Yeah, like going through the stress of trying to coordinate the ls at the end of the part. Why not, as we have already passed in the variable inside there, we have gotten the part, right? We have used and get env, then we have passed in the part, we have get the part. We now have it inside our env function to execute. So if we don't pass ls, so rather than it, now let's check inside that part part variable we now save inside our env. We check that file exists rather than like add it at the end. Wouldn't that work?
Okay, no, for you to check if a file exists, for example, now you need to give the full part of the file. So let's say /bin/ls, right? This is the full part of ls now, right? But now what I typed was just ls before. So I need to get the different part. All these are different parts, right? For example, that bin now is I don't know where it is. So let's say, for example, this is a part user/sbin/this, right? So because I only typed ls, right, I need to get each of these parts, then now append that ls to the end. So add slash and append it to the end before you can check the status. You cannot just, like, there is no, among the allowed functions that we are allowed to use, you cannot just take a part and now say, hey, I want you to look for ls inside this part. Even though the part doesn't end with ls, I want you to look for ls. It doesn't work like that. What you have to do is, it has to end with the name of the executable file that you're looking for. I don't know if you get. So it has to end with the name. So if I want to look for ls inside this folder called bin, then I need to put /bin/ls. I can't just say /bin. I can't just say, hey, go to the folder called /bin, then look for ls. I can't do it. I have to go to the folder /bin/ls and check if that ls exists. And this ls now is not appended to any of these strings. They just end with bin. All of them end with bin, ending with bin, ending with bin, most of them. So I need to put that ls. For example, if I type ls, or if it's echo, I can put /echo. So I need to put that slash and append it at the end, so that it will now be a complete string that has the part name and the executable at the end. Then I now pass it into the function and say, hey, look at this file part from the beginning to the end and check whether this thing is valid, if it exists. So I don't know if that makes sense.
Okay, if I get you now, if I get you now,
yes.
You know, when you're using execve,
yes,
you need to give it a part. That's the very first for should I say at index 0, you give it the 5 part, right? Just like you did before, bin/ls.
Yes.
So you know that you can't do this manually for all the functions. So if I understand you're saying you need to create a function that would on its own take a particular command being given,
yes,
and then append it to that's let's say /bin/ append it there,
yes,
and then use that as the new 5 part for
exactly
your execve function.
Yes.
Okay.
Yes.
Okay. I think I get it now.
Yeah. So that's what I'm planning to do. So I know it's not. I'm still trying to see if there's a shorter way to do it, but this way I told you is just the way I'm thinking of it right now. So within the constraints that we have, because again, I told you there's a function called getEnv. If you call it and you just pass part PATH in quotes, it will just give you this part alone. So when it gives you this part, you can now use your function for splitting like this one I created. You can pass in, like I can pass in this part variable, then I can pass in my delimiter, which is column. I can say, okay, split this string by column and give me each of the parts in a separate string. Then I can now be calling each string one by one and use another function that will be appending it. So, you know, they are different, but I don't know if getEnv is allowed because it's not in the allowed functions. So it looks like we are going to have to create our own function that will be able to read this whole thing, and you'll be able to specify and tell it, hey, give me old pwd, and it will give you this. Give me user, I need to give you this. Give me path, I need to give you this. Understand? So like we need to create our own function, and you know, this is C. It's not like Python. In Python it's just very easy to just use dictionary, but you know, so this is the kind of work that is involved. So the main thing is to understand what you need to do. So that's what I'm planning to do. So it's going to be a lot of work, and we have like 5 days, so this will be like a lot of sleepless nights. So, but you know, the main thing is that we are learning. So even if it is only, like I said, even if it's only mandatory tasks you do, you'll still pass. So me, I want to try and see if I can do all of them. It's not easy. So that's
but the mandatory task now involves this part.
Yes,
now.
yeah, mandatory
This
tasks involve
handling
this
the part
part.
is one of the mandatory tasks.
Yes, it involves that.
My God.
Involves
Okay.
that. So that's just attention. So I think that will be it for now. This, I don't know how long this recording is. This is 2 hours now. Okay. So I think that will be all for now. So let's end it here. Then I'll just try and compress the video and send the link. So maybe at least I believe that those of us here, at least you have an idea of how to at least start and do 1 or 2. I know, again, there's no time to explain everything. There's so many things. Even me, I'm still working on my own. So I just hope at least I've been able to like give you a direction on how to go about it. So I guess,
Yeah, right. Yeah. Thanks.
all right. So no problem, and thank you guys. Let me stop this.